Hello everybody! As promised in this video, I'm going to show you a formula for the expected distance. So it's not going to give us precisely what the expected distance of a random walk is, but the idea is that as the number of steps we take grows larger, this formula is going to become more and more accurate. So I'm about to show you what it is, but it's very cool. So I want you to keep in mind how simple this random walk is, right? So we start at 0 and you either move 1 to the right or you move 1 to the left. So we're really adding plus or minus 1, right? But the formula is going to involve a square root and pi. So it's very strange. I don't expect you to understand kind of where the formula comes from. I just want to show it to you as something very cool where we get kind of this crazy looking formula for something that's very simple. So let's take a quick reminder of this EV_walk1 function that we wrote in the previous video. What this does is you tell it how many steps do you want to take and how many experiments do you want to do, and then it returns you an expected value of how far you are to get from the origin. So on average, how far away from 0 will you end up? So let's try EV_walk1 of, let's say I take 20 steps and let's do 200 experiments. And we can see here I get 3.25. And so again, let me show you now the formula. It's not going to be precise, but it's going to become more and more accurate the more steps that we take. So the way it works is it's going to be square root of 2 times the number of steps, so in this case 20, divided by pi. And we can see here we get 3.5. So pretty close to our estimate, but what we're going to do is we're going to write a script and we're going to kind of plot this estimate versus our expected value. So what I'm going to do is I'm going to not open, let's do a new script. What I'm going to do, so I'm going to set my x values on the plot to be how many steps I want to take. So I'm going to start with 10 steps, go up by 10 steps, end at 500 steps. Then I'm going to have two different y values. So the first set of y values, I'm going to initialize both to be just empty vectors, but the first set is going to be the formula, so what we get from the formula. The second set is going to be what we get from our expected value function. So let's do it. I'm going to say for I equal to x, so again, first we take 10 steps, then 20 steps, all the way up to 500 steps. y1, so this is just our estimate. It's going to be y1, add on the value square root of 2 times the number of steps I divided by pi. y2 is going to be the results of our function. So it's going to be y2 comma EV_walk1 of, okay, so I steps, and let's do 5,000 experiments. Going to end our for loop, and now let's plot. So I'm going to plot, so steps, comma, first the formula values, and I'm going to have it with the default plot setting, so default color and kind of how it draws the line. Then I'm going to have x, comma, y2, and let's have it plot black x's. So I'm going to save this, and let's call it, let's see, formula test or formula plot. So saved, and now let's run it. So formula plot, and let's see, it's going to be running for a little bit of time. I might pause the video to see if it takes a really long time, and I'll kind of fast forward. So I'll see you back here when it's done running. Whoops, hello everyone. I realized that my code was running. This number is way bigger than I wanted it to be. I just wanted this to be 5,000. So let's fix it. There, that looks a lot better. Let's save it and run it again. All right, that ran about the time I expected. Sorry again about the little mishap with this much larger number than I expected. But here we can see, so remember, with the blue solid line, that's our formula. And the X marks, these are our expected value estimates. So we can see here the formula does a pretty good job of kind of predicting these expected values. So again, I don't expect you to understand where the formula comes from or anything like that, but it's a very cool example of kind of these interesting kind of transcendental and irrational things showing up when our problem was pretty simple to start with, right? We were just adding plus or minus 1. So this concludes the video. Thank you for watching, and I will see you in the next one.